Hello, Ian. It's great to be back with you.
Yes, very good to see you again, Alex. What are we
Okay,
talking about today? I
it's
think it's
chapter.
science, isn't it?
Yes, it's an important topic. It's getting more exciting as we go. Chapter 11,
Yep,
Science's Claims on Truth.
yeah, yeah. Right. Yes.
Let's start unpacking this. How to begin?
Well, one of the things I suppose is to distinguish at the outset what we're asking science to do. Obviously, science can give us information. That's the least it can do. Any kind of experimentation will give us some more data or information. Now, the question is, can that be converted into an understanding? And what part does science play in the achievement of an understanding?
Mm.
And to give a sort of example of the distinction I have in mind, um, imagine somebody watching a ballet dancer, and this person asks, well, what is happening here? Well, one way you could answer it is by talking about skeletal muscle and how muscle fibers and filaments work, how they contract, the chemistry of it, and so on. But another way completely would be to say she's a dying swan. I mean, these are completely different understandings.
Mm.
Um, and I think that probably the bigger the human meaning, probably the less science can contribute directly. It can't
Mm.
answer the big questions like what is love. It can tell us what the accompaniments of experiencing love may be. Possibly they might even be able to do that in the brain, although I'm very skeptical of that. But even if they could, that would just show us what's going on in the brain, not what actually it is to be in love. Nobody looking at that who'd never experienced love could work out what love was from the brain scan.
Mm.
Absolutely not. So science gives us mechanisms often, but it gives us much more than that. It helps us to put these things together so that we do achieve knowledge of and an understanding of the world. It would be foolish to say that science hasn't enormously changed our understanding of, say, the nature of water, or um, how radiation works, what it is, where it comes from, how we can control it, what it's for when it occurs naturally.
Mm.
There are a limitless number of aspects of the physical world that science potentially can illuminate for us.
Mm. Yeah, that example of the ballet is very, very useful. I have a friend who often says, "Well, if you are asked to explain New York to me, how would you do it? I mean, you could describe the geometry of the streets or the chemical composition of whatever the
Yes,
restaurants. But this immediately puts limits on science, which is something that some scientists, I don't know if many, but at least some scientists, and also some non-scientists don't like for a strange reason,
yes,
right? In
yes,
this path for truth, there seems to be a hierarchy where science is at the
yes,
top. This hierarchy easily turns into just one, and the other we could dispense with the other, and then science
mm,
is erected as this only path to truth, and
mm,
therefore any consideration of its limits is not welcome. But in a way, what you're saying here is, well, we should be very honest about its limits. Nevertheless, again, people will say, well, but you say it cannot show us what love is now, but it could in the future. And that attitude, which is understandable,
mm.
easily leads to scientism 101.
Yes, exactly. It's no disrespect at all to science, which I value hugely and which, of course, I've benefited from in my personal life, as we all have, but also rely on professionally to a huge extent. So it's no disrespect to science to say that there are such limits. And what I find is that good scientists are generally quite skeptical of huge claims made on behalf of science, almost in proportion to the greatness of the scientist. They are the people who sound the warnings. Whereas it's often non-scientists who, in an interesting way, have become rather dogmatic about science. And it seems to me that this is a failure to understand what we're dealing with when we're dealing with science. One of the things that is very hard for science to deal with, if not impossible, is all that is experiential. Because if science makes a claim that what it deals with are simply matters of fact that can be measured, most of what we value in life comes to us experientially in a way that is not factual and observable from the outside, nor measurable. So this is obviously one of the areas that we need to be a bit skeptical about. Yeah. And on the whole, one might distinguish also the left hemisphere's idea of science. In other words, a left hemisphere congruent idea of science would be of maps, diagrams, theories. In other words, representations of reality, because that's what the left hemisphere deals in. And much of science is, in fact, representational in that way. It's not concerned with and can't concern itself with the direct presence of something, because that is felt within the consciousness of the observer. And science has traditionally alienated itself from that part of our lives.
Yes, you have a line in the book that it's worth quoting now. You say, you're right, the idea that only factual statements have validity is to be not only dogmatic, but self-contradictory, since the statement itself is not factual.
Exactly. No, that puts it very neatly. I think I'm quoting Ashleman there, yes. But it's a very good point. And it touches another question, which is, does science actually do without judgments and do without values? In short, I think it doesn't, but that in no way means that science is diminished in its value. It's just that we can't do anything as human beings without making judgments and without relying on values. For example, there's something called the fact-value distinction, and the distinction is good, but the separation is bad. In other words, these are distinguishable aspects of mental life and experience, but they are not. They're not to be completely sundered. They don't come from completely separate places and have nothing in common. Because, for example, the inclination to require factual proof is itself a judgment. It's a judgment that facts actually have a certain kind of value for us, that they have certain qualities which we call their reliability, their reproducibility, and so on.
Which
it's also... No, go on.
Please, no, I mean, this made me think of, well, this quote or this statement by Ortega, the Spanish philosopher, who speaks about values too. And he says, well, perhaps often when we speak about science as if it had no values or is not pursuing values, well, what it's delivering, at least in its more technological form, is comfort, which is a value we all appreciate, but there are others. And this ties with what you were saying at the beginning, I think, because when we use science to predict and control, which we all in a way want and need, this can afford, comfort, security, which are values. But then there are other things that we would wish to have with or without science, which is knowledge or understanding of what's going on. And again, here's where we need to draw from the humanities. And we can draw a distinction, as you're saying, but perhaps not a separation between the science and the humanities, but there's always a value or some values at play. And maybe then maybe we could discuss briefly these different aspects, right? The facts and the data, the explanations we can draw from them, the interpretations, theory-laden predictions. I mean, this is all this universe of words that PhD students, for instance, and tend to conflate all the time, and not only PhD students. So it's good to say what we're talking about and this kind of gradation.
Yes, well, there's a lot to be said there, isn't there? One of the first things to say is that science cannot escape using models and metaphors, because models and metaphors are at the base of all understanding. A point made at great length in the work of Lakoff and Johnson, Philosophy in the Flesh and Metaphors We Live By, which I think makes a very convincing case that all language is in its origin metaphorical, and that science and philosophy particularly depend, because they tend to be rather abstract, on metaphors derived from concrete experience. And one of the things that we think of as a step forward in understanding achieved by science is when science shows that something is like something else that we think, oh, I understand that. And so there's usually a primary model that science is trying to liken what it is looking at to. And in the past, this was often something in the natural world, such as a river or a tree or a family. But for the last couple of 100 years or more, it has really been the machine. It may not be specifically mentioned, but it is there unspoken in the background that when science thinks it has explained something, it's likened it to a mechanism. So something very practical that we as children can play with and put together and have control over is the model to which everything in the cosmos is in the end likened by science, at least by contemporary science. It's not built into the nature of science that it has to use that model. I'm just saying that that is the model that is used and has been used for a long time by science.
Interesting step.
And of course,
it's an interesting step because you value, well, you acknowledge the pervasive, inescapable use of metaphors as that thing that allows to make the unknown familiar. But then immediately you point out that we have kind of collapsed all the possible metaphors. Like if you think about Cajal, and he uses, when he writes about neurons, he speaks about gardens and jungles, which is a very natural way of making this bridge of what these things are. But we've collapsed most of our understanding into the machine metaphor to a degree that it seems that it's literal, that it's a fact, not just one tool to imagine what we're dealing with.
So that's one of the things we need to guard against, is thinking that this is a literal truth rather than a metaphor that has its uses. And the next thing we need to see is that any model affects what it is that is being modeled. So when we model something as a machine, all the aspects of it that look rather mechanical stand forward, and all the bits that don't recede into the background and we don't see them. So in other words, when we're making these comparisons, we're actually altering the object that we're looking at, which again is a reason for thinking that grand claims of total objectivity are probably a mistake. But as Einstein also pointed out, you may think that observations shape the choice of a model, but the choice of the model shapes the observations you make. So there are certain observations that you won't make, you won't even think of approaching or see with a certain kind of model, but you would see them if you had a different kind of model. And as you know, because you have read the whole of this book, I am going to suggest over time, particularly in part 3, where I'm looking at what can we say about the nature of the cosmos, that in fact the idea of a machine is not functional, and that ideas of flow, seamless flow, such as exist in water, in rivers and so forth, with their whirlpools and their waves and so forth, is a much better family of resemblances, of metaphors that enable us to see things as they really are.
Yeah, so there's a hierarchy
because when I say,
here.
yes, and when I say, as they really are, one of the first things one has to face up to is, if you've read part one and agree with me so far, that there's bound to be a degree of judgment because each hemisphere will present us with a slightly different picture of reality. So right there, we're not actually dealing just with one version of reality, but already with a couple that need to be chosen between. But what I want to emphasize is that doesn't lead to chaos. All I am saying here, none of it should be taken to mean that somehow science is not something hugely valuable, dependable, and reliable. It's just that ideas of 100% truth cannot possibly be sustained. These are completely unrealistic, and in a way, they're sort of naive demands to make of science. But what we can say about science is that certain things will be neglected, those that are not pinpointed by the model we choose to use. We may get rather stuck in the left hemisphere, somewhat dogmatic way of thinking in science, or we may free ourselves from it. We may think that only things that are quantifiable are real, whereas in fact all the really great things in life that we experience that give it its meaning are not quantifiable in that way. So we've got to rethink the idea of objectivity.
Before we go into it, let me just mention, because we speak about metaphor, we speak about model, and there's a third M, which is metaphysics. And I like to say that these three M's are, we do kind of sleights of hand. And so we're presented with a metaphor, usually the machine one, then pretend it's not a metaphor, but it's at the same time used as a model. And as you were saying, to me, a model, the moment you have a model, you've decided what's going to be signal and what's going to be noise. And the whole use of a model is that you're going to neglect the noise to concentrate on the signal. So it reminds me of this famous video of the gorilla. I'm sorry if somebody hasn't seen it, right? Like if you pay attention to something, like counting how many times people do an action, for instance, and there's something in the background, you will literally not see it, which ties very well with part one of the book. And then there's the third M, which is metaphysics. And so in choosing a metaphor that's acting as a model, sometimes we scientists sell to ourselves and to the public a whole metaphysical scheme. And then we need to untie all these knots, because if we do so, which is fine, but we forget we did, then we come into all these troubles of interpretation and also the consequences of being stuck with one view of the world that actually, and this is where you add even more material, it's probably inferior to other metaphors, other models, and other metaphysics.
Yes, although no one model will ever be the perfect fit. I'm just recommending that we try a different model. And I don't mean just look at it and go, well, that's nothing like anything I've used before, I can't use that. But actually try, experience it, give it a proper test and see what it shows. But in due course, we may want to jettison that model or metaphor too. So there isn't just one model or metaphor. And your point about metaphysics is a very good one. I argue strongly that science and philosophy have lost enormous strength and power through their divorce over the last 250 years. I mean, science in origin, the word literally just means knowledge. And philosophy is always bound up in ways of knowing. And so philosophy can benefit from science. Some philosophers think that science can't teach them anything. And while I'm sympathetic to the idea that philosophy doesn't depend on the certain outcome of an experiment, it's nonetheless true that if philosophy is trying to create an understanding of who we are and what the world is, then science is bound to come into it. And for example, the science that reveals that the two halves of our brain actually literally produce different versions of the world is surely something that philosophy needs to take into account. But equally, science can't just dismiss interest in philosophy, because as soon as it does that, it becomes hugely vulnerable to a very simple philosophy, that of reductionist materialism, the mechanistic model, which has led to so many problems for us and may jeopardize our future on this planet.
Yes, there's a quote on economics that I don't remember, that I gloss, and I use it with respect to science and philosophy. It's a famous quote on economics, and in this case, it reads something like, well, if you pretend or you think you don't have a philosophy, then you're enacting one of a defunct philosopher and you don't know it.
Exactly.
So
That's it.
So there's this striving for universality because I'm going to lead into objectivity, which is what you were talking about. There's this striving for universality, but that, which is a nice, I would say, a valuable drive, easily ends into kind of generalization that's made dogmatically. And this kind of generalization seem to require us to pay the price of divorcing myself from what I'm talking about, or pretending I don't have a philosophy if I want to do science, which again is, we've talked about this over and over, is this idea of separating content from context. And objectivity is, to me, is a kind of an instantiation of that at a meta level, because it's this idea that, well, if I can say something about the world where I don't play any role at all, and first, the belief that that's possible, and second, the belief that that will give me a truer vision of what I'm trying to say, which is, we do it all the time, or many times, but it's rather strange, like this divorce, like, I don't want to participate in this, and if I don't, it's going to be better. It's like, but it's going to be a better quality claim. Science's claims on truth is what we're discussing. Like the idea it's going to be higher quality if I'm not there.
Yes, and again, there's a logical fallacy involved in that the idea that we should particularly value a vision, which is a very odd one for any human being to take, of the world, in which, as far as possible, we remove ourselves, our thoughts, our feelings from the picture. Why we should necessarily think that this aids our understanding. It might do, of course, but it might very well lead to something quite different, like a complete misunderstanding, and that a more engaged attitude to the object of our attention would reveal more about it. So what I want to work towards is an idea of objectivity as not one single, very peculiar way of looking at the world, but the ability to inhabit a number of possible perspectives and to be honourable towards the idea of truth in doing so. So, in other words, to have a disposition, which is a serious disposition towards the world, a disciplined disposition, in which we certainly don't just follow things that seem to us to have no basis in experience and no good arguments going for them. So we don't have to try and inhabit absurd points of view, but we ought to try at least to see from different perspectives that have something going for them in our experience and have revealed things to us in the past. And, you know, again, one problem is that even if it's not actually ruled out, the immeasurable is largely left out in science. So simply because it can't be measured. The very fact of its not being measurable means that it doesn't get talked about. So that's something, again, that we need to be aware of, and that it's not simply a case of there being a clean take on the world that is always going to be right. But again, I don't wish any listener or viewer to go away with the idea that what I'm recommending is a free-for-all in which we dispense with the incredibly valuable knowledge and understanding that science does bring to us.
Yes, there's another aspect of it. There are many aspects in this chapter that also help me kind of better clarify my thoughts. And you cite John Stuart Mill, and you say it's not so much about embracing, well, he says, it's not so much about embracing falsehood for truth as mistaking part of truth for the whole. I think this insight is very good, because we're not talking about right and wrong here. It's more about local and global, because the machine metaphor applies well in its local domain. Now, the moment you forget that it has a local domain, you erect it as something that works globally, and that's the big mistake.
That's terrifically important point, and made in very similar terms by A. and Whitehead. And he said, there are no truths but half-truths, and it's treating them as whole truths that plays the devil. And he also said about scientific discoveries that the question is not simply are they true or false, but under what circumstances are they true, and under what circumstances are they false.
Yes.
So I think getting that perspective to play, and I love your pointing out the local and global, because it reminds me that you were talking a moment ago about the idea of laws that are universal and eternal, but we don't know those. Those were the sort of assumptions that were made in the 17th and 18th century. But now, with a greater understanding of physics, many physicists are saying we can't rule out that what we take as eternal and universal laws are local habits of the part of the universe of which we are aware. Logically, we can't exclude that, and logically, we can't just assume that they must be eternal and universal. Or indeed that the constants that we think we have measured finally are completely constant. I mean, I know this is a small point, but it is an interesting one.
Yes.
That they do vary, and
Yes.
I talk a bit about the ways in which they have been found to vary, only minutely, it is true.
Yes, and our friend Rupert Sheldrake has written about that explicitly
Yes.
in his book, right?
Yes.
And it's not just, and that would be enough, but it's not just a fringe divertimento about, okay, let's try to shatter these solid foundations. No, because metaphysically and also experientially, it's super powerful. Like if we think about Whitehead's philosophy, that he has as a cornerstone, and already cornerstone implies something static and solid, but in any case, the cornerstone is creativity. And in a universe where evolution is going on all the time, it's not finished, it's not done, and where things can change and meta things can change, and that can lead into kind of process theology. I mean, this is derailing a bit our conversation, but I'm just mentioning that process theologists using Whitehead rethink our understanding of God as, for instance, omnipotent.
Yes.
And this is mind-blowing, because just to entertain the idea that, well, that praying is a way of persuading God, right? And that he, or whatever, he or she can do everything it wants at any moment because the universe is creative. I mean, this has huge implications for just conceiving nature and what seems to be beyond nature in very different ways.
You're right, Àlex, of course, but I'm going to resist the temptation to follow you down this enticing rabbit hole, because it's something that we will undoubtedly talk much more about at a later point.
Yeah.
But you're right that everything connects in this way. But I have particular things to say about the concepts of omnipotence, omnipotence, and omniscience, because I think we misunderstand what we're talking about there. But let's not discuss too much.
Let it be a teaser. Let it be a teaser.
Let it be a teaser.
Chapters, in 10 chapters time or something like this. Well, back to half truth. Well, let's just go back to half truths and true enough, because this emphasizes your point. Sorry, that it's not about this is the truth or anything goes. There is a position that's more subtle, and that's reflected by these two expressions that we are recently repeating: true enough, or half truths, or local truths.
Yes, unfortunately, we live in a world where if you question something at all, you appear to be stating the precise opposite. We veer unstably between black and white positions, whereas the whole of my life's work, in a way, is devoted to trying to get conversation into a subtler, more nuanced area in which some aspects of this are true and some aspects of something else that look as though they're excluded here are not. So that's, I think, very important. And actually, science is the better for it, because if we make enormous grand claims for science, if we once see that they are not supported, we endanger the whole enterprise. In other words, we've made it in Nassim Taleb's sense, we've made it robust and therefore vulnerable to any cataclysm that comes. Whereas what we need to do is make it anti-fragile. And that means showing that, yes, there are gradations, but there are absolute huge strengths of science, which we must never lose hold of and never disparage. But one way of misunderstanding them, representing them, and therefore actually weakening their capacity to convince a skeptical human being is by making too great statements of too absolute a nature.
Yeah, yes.
So, yes, I mean, I think it would be useful just to think about the idea that science makes no assumptions and that it achieves its goals by following a method, because I think both of these are questionable. It's certainly something I've referred to already, the case that statements that involve the non-externally factually observable and measurable nonetheless will have validity, although according to the version of science that's put about, science makes no assumptions at all, but it does make assumptions that those things are not valid if they can't be externally observed and measured. And it also makes the assumption that everything is not only understandable, but understandable in physical terms. What that understandable means must be understandable to the human brain, because that's the best we've got. But it's illogical and irrational to suppose that there cannot be things in the universe that we could not know with our brains. For example, there are certainly things that we know in the universe that a mouse couldn't know. A mouse is somewhere on an evolutionary tree where we consider ourselves further on that tree. And there'll be, if we survive in this world, evolution will continue. And it's perfectly possible that a different kind of a brain or a more powerful version of whatever it is that our brain is evolving towards will be able to see and understand things that we simply can't now. So the idea of ruling out things that don't seem comprehensible rather than taking a more skeptical position that there may be something here that we're simply not grasping is quite an important one. But I'd also like to draw attention to the second part of that assumption, not just that everything must be understandable, but that everything must be physically understandable. Now, if you are actually in the business of reducing the number of assumptions that you make and the extent of those assumptions, then this automatically is a problem, because the simpler assumption would be that it's understandable. In other words, we could understand it in ways that include non-physical. But the much more narrow assumption that science apparently is making is that it's got to be physically understandable. But why does it make that assumption, all the while claiming that it makes no assumptions?
That's interesting. You're alluding in a way to Occam's razor as a way to cut somebody else's throat, right?
No, I think sometimes one may be justified in making assumptions, but if one is, then one must state that one is making assumptions, not that one is making no assumptions, because that just isn't the case. And some of these are really quite important ones. They're not trivial ones. For example, science, a lot of people understand science to have demonstrated to us that the universe is purposeless and that human life is purposeless. But in fact, it has done no such thing. In fact, it would be impossible for it to do so, because it would have to take into account things that science is already ruling out. But it starts from a position that it is not going to conceive of things as being purposeful. That would sound to it somehow like we were attributing a conscious drive to elements of existence that science is going to say don't have such a conscious drive. But it's no surprise that at the end of the process, having cut purpose out from the start, it then appears to announce, well, I've had a look at it and none of it has any purpose. Well, of course it doesn't, because that's the very thing you started out by rejecting. So I just want to make that point, not again to suggest that necessarily science needs to do anything very different, but just to sophisticate people's understanding of what science can do, which is very, very much, but not everything. It can't answer the ultimate questions at all. In fact, about things like the divine and the sacred, it can have absolutely nothing whatever to say, in my view. There we are. There's another point, I suppose, that's worth making, which is about the disparity between the myth that science has a process called the scientific method, which is how it reaches its conclusions, and the actual experience of scientists, which is completely different from this. And in brief, everybody knows that the scientific method involves the idea of having a hypothesis, and you mustn't make assumptions about that hypothesis, and you must test that hypothesis to see whether it stands up to empirical experiment. In other words, is the evidence in support of this hypothesis or not? So this is a linear logical sequence of steps, but it goes awry very near the beginning, because first of all, you can't test every possible hypothesis. Most of them are completely absurd, and we wouldn't give them a moment's consideration, like that the moon is made of cheese. We wouldn't set aside a $1 billion grant to actually go and experiment on the moon and find out whether it really is made of cheese. So clearly we have hypotheses that we think stand a good chance of being right. And in that comes judgment, and there's nothing wrong with that. We select our favorite hypotheses, the ones that look, from what we know so far, to have a sporting chance of proving, possibly right. So we select hypotheses, we don't just deal with them in a machine-like way. And in fact, what then happens is we certainly do experiments, but the big insights are not made by following a step-by-step procedure in which we lay down one stone after another on a pathway that leads us to a goal, but is often completely different from that, with ideas coming from other places, not linear at all, but coming from things that are going on at the same time in our minds at an unconscious level, pattern recognition, the remembrance of things that we'd excluded because we were dealing with this experiment, but when we relax, we remember these other things that come in and qualify what we're thinking. So scientists and mathematicians almost invariably describe their results as coming to them in a flash of intuition, which is not to say they don't do a lot of hard work and slog at some point in the process. I've already talked about that a bit when we talked about creativity.
So this is a kind of post hoc. Sorry, it's a kind of post hoc meta narrative of what was done, and you
absolutely.
And the section. Please go ahead.
No, what's important about that is this is exactly what the left hemisphere does when it tries to account for anything. So we live life, as it were, from moment to moment, largely unreflectingly. But when we reflect on what happened, our left hemisphere then gets to work creating a narrative. So when I came into this room, I did a survey of the various elements in the room. I did it very super quick, and I brought them together, and I thought, yes, it's got all those things, those make it my living room. But this is nothing like what actually happens at all. So it creates its own step-by-step logical procedure whereby we know what we know. But in fact, that is one of the fantasies of the left hemisphere. And although it's clothed in this respectable scientific-sounding garb, it is in fact garbage.
Well, I wasn't expecting that comment. It's very helpful because the following chapter, which is a study on left hemisphere capture. This is the subtitle of the following chapter. Well, here we're talking about this too, but maybe not in the sense of the next chapter, which is about the life sciences as a domain of study, but more as the very same thing we are told to ourselves and to the public that science is. And
yes,
so we say that science now has shown these facts, and we discussed about how complicated it is to talk about facts as if they were these pure things, and also the way scientists are supposed to find them is also narrated. And maybe that's why you use in this section of this chapter, this subtitle, which is the myth of the scientific method, because that's how it is explained that it happens.
Yes.
But it has
something,
but it doesn't map completely how actually scientists do it.
That's exactly right. And of course, I use the word myth there, as I do throughout the book, not as a judgment that it is not true, but just as a description of what's going on. It may prove to be a true myth or a false myth. And usually myths turn out to be partially true and partially false. So it has a certain degree of truth about it. But it is a myth. And what I want to emphasize is two things. That science cannot avoid having its own myths, its narratives, indeed its rituals, its metaphors and its models. To expect it to do so is a basic logical error. But the other point I want to make in the same breath is that this does nothing to undermine science. It only undermines a somewhat idiotic view of science known as scientism, which is the simple-minded idea that science will just answer all our questions. Of course, it never can. So it's just to make those 2 points. And actually a further reflection, and then perhaps we might, having had a suitable pause, we might move on to talk about the next chapter. But I just wanted to say, you mentioned John Stuart Mill earlier, who I'm sure most people find, as I do, is always a very sane and thought-provoking mind. And he went on in the passage that you quoted to say that very often proponents of a certain theory have been right in what they proposed, but wrong in what they opposed. And that if instead they'd been able to embrace some of the things that they were opposing, along with the true things that they had latched onto, we would have made a real advance rather than just another step in a combat between two different positions.
Yes.
And I know if I can just reflect on that very briefly, my view at the moment is that it is not necessary to take down the achievements of reductionist materialist science in order to see that there's much more than reductionist materialist science can deal with. So it's not a battle to the death in which one has to be wrong and the other has to be right. It only becomes wrong when it says, I am the whole truth. Yes. As long as it realizes it's onto a little bit of truth, then we're fine. But that's not what actually happens. That's not what's stated. And again, we come to that point you made earlier about local and global, which I think is extremely important and comes back time and again during the book, that I show that scale changes the nature of something, that what is true, it's a thing that we, almost every chapter actually, I will probably in one form or another be making the point that what we see at the local level is not a guide to what we see at the global level. And indeed there may be intermediate levels. For example, I think it was a point made by Freeman Dyson that when we look at the sort of most evolved levels of biology, of human imagination and so on, it looks not particularly mechanical. But as you start breaking it down and you look at the habits of a frog, it looks a bit more mechanical. And as you go down and you look at the way a cell works, it might look a bit more mechanical. Actually, I don't think it does, but there you go. Let, for the sake of argument, say it does. But as you start to go down and down into the physics of what's going on, suddenly it looks nothing like a machine at all. So there is a sort of mid-ground where it looks a bit mechanical, but at the top and at the bottom it doesn't. Yeah. And this is slightly like the whole business of, the curvature of the earth, that looking at it in a certain way, I go out in the garden, I can't see that the earth is curved. Yeah. If I want to build a garage, I don't have to take that into account. But if I want to circumnavigate the globe, I really do have to take that into account. Yes. So these things are different on different levels. Yes. I think that is really, really an important point, because one of the things that happens is we take a complex system, and in nature, almost all systems are highly complex. I'm making a distinction there, of course, you will understand, but not perhaps everyone is used to, between complex and complicated. So, for example, a jet engine is complicated. It's got a lot of parts, and you have to understand all the parts to know what's going on. But systems of weather are not complicated, they're complex, which means they are intrinsically unpredictable. They are intrinsically irreducible to certain formulae. And that is a very important point, because when you look at a very, very complex model, with a microscope, you see a little tiny bit in it where there is linearity, where you can isolate, yes, an arrow leads to something else, leads to something else. It looks like it's linear. So we've cracked it. It's all a linear system. No, it isn't. What you've looked at is the little tiny fragment that looks linear, but you can't build from there to that the whole system has that quality.
And back to your point about scales, I think it's Whitehead who has a quote, I forgot, but it says something like, when you look through a microscope, you're not seeing a zoomed in and enlarged version of small things. You're literally seeing a whole plane of reality, if you wish. And this is not just poetic metaphysics. The very construction of a microscope has in it these assumptions we were talking about, these projections, and it's a whole, like a microscope, it's an instrument, but that contains a whole theory in it with assumptions in it, and the realms that it allows us to see are not just what we are used with our own eyes, just tiny made big, but literally brings us into other worlds. And perhaps that's one of the reasons why when physicists looked at the smaller and smaller scales, there was this big surprise, like, oh, this seems to undermine everything we were so used to, precisely because this pictorial observation we have macroscopically may completely break down the moment you looked at smaller or bigger scales.
Yes, and that, of course, is probably the granddaddy of them all, how different physics becomes as you change the scale. So that's a good point. Your thing about the microscope made me think of another reflection which I would like to make, which is that reality is a nested set of wholes. There is a holarchy, as it were. And what looks to us like parts, we enlarge something and we expect to see the parts, but what we see are new wholes that at a different scale have their own parts, which at another scale are wholes themselves. So nothing is in existence as a part or as a whole. We're used to thinking like that because in the machine it's true. If I have a widget or a tappet, it is a part. And I have a machine, it is a whole machine. But nothing that exists that we didn't make in this way has this structure. There are no parts that are ultimately ontologically only part-like, and there are no wholes that are ontologically, well, I would be a little bit more cautious about that, because when you get to the very extremely large, the almost infinitely large, then it may become true that these wholes are themselves just finally wholes, and they can't be made parts of anything else.
Well, now you made me think of something you've mentioned before that was quite a surprise, and I think it's very deep, and it seems to come back here. I think it's when we were talking about dualities, and you mentioned, well, yes, let's try to think non-dual, but if we make this distinction or this separation between dual and non-dual, we're back again in the same place. So you seem to be saying this now for parts and wholes. Let's not say the part is the bad guy and the whole is the good guy, because parts themselves are also wholes at some other level. So let's escape again this debate between it's either this or that.
Yes, and just to say something that follows from that, we don't actually see the whole better when we think we're just looking at the whole and not taking into account what we call its parts. To see it whole, we have to take into account, yes, the whole as we see it, but also at the same time and indivisibly what we would call its parts. So that it's this business that we need differentiation and we need union, we need integration and we need individuation. We need these things together. And once again, to go back to the dual and non-dual, we need, as I say, not the duality of non-dual and dual, but the non-duality of non-duality and dual. Yeah.
Which is dynamical. Now, to add on this,
Dynamic,
it's very interesting.
exactly.
It's dynamic. It's not an apprehension that's static. Now you're saying you need to be shifting, which also fits into the process view the whole book is conveying.
Yes.
Okay.
And if we do move on to talk about biology, one of the things that has always struck me as so fascinating is that our image of a cell is taken from a textbook where it's drawn on the page, or from a snapshot of a micro photograph, which gives it the illusion of being solid and single. Whereas actually, if you could see all those things that looked like solid structures, the membranes, the organelles, are going and coming from existence and have permeable borders. So
Yes.
that's something we can talk about when we come to look
Yes.
at chapter 12.
Yes, and just a quick footnote there. While physicists gave up on the idea of finding atoms, in a way, biologists were so enamored with this idea that they postulated their own atoms as, whatever molecules or the bits that make the living structures, right? It's very interesting, this give and take of myths, and the other part of the community doesn't realize that it has been given up in this side of the map, but they're still pursuing it. It's a funny game in a way, to put it positively.
Yeah, absolutely. It's a very nice point.
Let me zoom back. Let me zoom back a moment, because you mentioned Stuart Mill and that quote about accepting what you affirm, but then also maybe what others affirm instead of negating it. And here,
Yes.
Just to mention for the listeners to read the book is filled with great surprises. So I think it's very close to that quote. You have one by Leibniz. It's a letter. I don't remember with whom Leibniz is corresponding. But it's a quote that a friend of mine had been searching forever, because we always discuss this Leibniz idea. It says something like, there are all these sects, and there Leibniz is talking about the followers of Aristotle and Plato and so on. All these sects, they're fighting amongst each other, and they may very well just embrace, like, they're correct in what they affirm, but they may be incorrect in what they deny about the other sect.
Exactly.
And first, to me, was like, I took a picture and I sent it to my friend. Finally, we found the quote. He was so happy. So this just speaks about your erudition, right? Like the fact that we can find that there. But also, it serves, it's not just an anecdote. It serves me to make the point that the more I'm reading you and we're discussing, you're so helpful in that you're not bringing here kind of rebel wisdom. It's an integrative wisdom. It's a wisdom. It's not about saying, look how naive and stupid these sophisticated ways of thinking are, because mine is more sophisticated. It's really, really an effort of integration, and that's very badly needed and very, very difficult. So thank you.
Yeah. Well, thank you too for making that point, and I think it's a fair one. That is what I strive to do. It's certainly not to stand in a position where we are in judgment on those inferior beings who came before us, but to try and grasp some of the wisdom that they had seen that we may have lost, and if possible to build together the most valuable themes that come to make a surprising whole. Well, there we are for today.
Yes. Thank you, Iain, as always.
Okay. Thank you very much.
My pleasure.